Hello everyone, welcome back to the course Infrastructure Asset Management. This course is offered under MOOCs, an initiative of Government of India. In this week, we were focusing our discussion on data collection. Within data collection, we saw that there were different aspects. We talked about the role of data, different requirements for data, categories of data, and so on. In the last lecture, we saw prioritization of data. We saw that it is important to prioritize or identify some of the important data sets because it is very challenging and difficult to collect all the data. In this particular lecture, we will be focusing on handling missing data. Missing data basically means that for some reason, some data is not available with you. It could be because you are using some faulty instruments which did not record the information, or there was a human error, because of that you do not have the data, or there was some loss of files. It could be any reason, because of that you might have missing data. Now the question is, how do we handle this? Before moving to handling missing data, let us discuss what are the issues if there are some data points which are missing. So what are the potential issues due to missing data? First, it can lead to biased and misleading outcomes. Imagine if there is a scenario where some of the key data points are missing. In that case, you might get a result which is flawed or misleading. Second, it basically leads to reduction in sample size. You have a situation where if a lot of data is missing, the available sample size which you have is much smaller. A smaller sample size means you have reduced statistical power. Now you cannot use some of the techniques which require large sample sizes. The third aspect is issues in analyzing data. Depending on the reason behind why data is missing, analysis can become tricky. We will talk about different aspects of how can we categorize missing data. Next, overall missing data makes our results less dependable. If we need to calculate mean or some correlation, obviously our data will be not 100% accurate because you do not have all the information now. Also, there are some ethical implications. What if the missing data is intentional? Someone has intentionally deleted some of the data points. This raises another concern that maybe some points are hidden because someone has done that intentionally. So there are ethical implications. And finally, there is a possibility that there is some analysis which requires complete data. There is no other way to do an analysis if all the information is not available. And we understand that recollecting data is difficult. First of all, it is costly. Sometimes even it is not possible to recollect the data. For example, say you have temporal data. Now, once the moment has passed, you cannot collect that information again. So data recollection is difficult. So the idea of this particular slide is that we should try to ensure that as far as possible, we have the complete data set available with us. We should take all the steps to ensure that the relevant data which will be required for decision making is available. However, no matter what we do, there are always situations where there are some data points which are missing. Now the question is, how do we process such information? How do we manage the missing data? So this is the focus of this particular lecture. Now let us discuss how do we mitigate the impact of missing data. The first one is preventive measure. This is obvious that we should take all the necessary steps to ensure that all the information gets collected. It includes calibration and standardization of all the tools and equipments which will collect the data. It also includes periodic checking of all the data sets so that even if there is a missing data set, it is highlighted at the right time. One can also have some quality checks to ensure that all the information which is collected is making sense, because a data which is inaccurate eventually leads to missing data. So preventive measures includes all the steps that can be taken to avoid the issue of missing data. As I have discussed, it is very difficult to ensure that you have all the data points. So, the next technique which is available is imputation techniques. I will be discussing about different ways of imputation. The idea here is that if a data point is missing, can we use some method to make an educated guess about that particular data, or can we get rid of that data point altogether? So, we will discuss about different imputation techniques. Finally, in order to mitigate the impact of missing data, we also need to understand that what is the effect of the data which is not collected on the overall decision. That is, we try to do an analysis to understand what is the impact of missing data on our decision. Sometimes it is possible that we do not have a very critical data point which is required for the decision. Then the impact of this particular missing data is very high. So, we will need to really ensure that we find a way to accommodate for this missing data point. On the other hand, we might have some missing data which are not contributing to the decision. So, we need to understand what is the impact of missing data. Let us discuss some of the imputation techniques first, and then we will come to understanding the impact of the missing data. First important step to handle missing data is to understand what is the reason for missing data, why we do not have all the information that was required. Oftentimes, the answer lies in this particular question. Once we know what is the reason behind missing data, we will have a better understanding of how to accommodate for missing data. So, if you go towards data science or data analytics, you see that missing data is often classified in three ways. The first aspect is MCAR, which is data missing completely at random. The second is data missing at random, and the third is data missing not at random. So, I will discuss these in detail in the next slide, but for now we need to understand why the data is missing. Additionally, we need to understand what is the impact of the missing data, and these two questions basically determine how we will handle missing data. So, now first let us discuss what is MCAR, MAR and MNAR. Please note, in this particular lecture we are discussing different aspects of missing data. However, I will just give a brief overview of what are the reasons for missing data and some of the techniques. If anyone is interested, you are encouraged to go over any books around statistics or data analytics, data science, where a lot more detailed discussion is available. Having said that, let us discuss what are the different types of missing data. So, first is missing completely at random. The idea here is that the data which is not available is purely random. That is, there is no relationship between the missing data and any other observed data which we have. There is no pattern behind why data is missing. For example, let us assume there was a blood sample that got dropped in a laboratory. Now, obviously, the data around that particular sample is missing. If it was a completely random act, we say that it is MCAR. That is, there is no relationship between the missing data and any other observed data. For example, say there is a human error which is happening because of no particular reason. There are human errors in the data which is collected and it is completely random. Then this is known as MCAR, missing completely at random. Another category of data is MAR. MAR stands for there is some pattern in the missing values, and what we are trying to say is that this pattern can be explained with the help of other variables. So, for example, if in a data set you have 5 variables, variable 1, variable 2, so on till variable 5, and there are some data points where variable 1 is missing, but what you are trying to say is that there is some pattern which can be understood based on other variables for which information is available. So, you are saying that there is some pattern which can explain why a given data is missing. Let us see an example of this case. Say you have a survey data, you have all the data points and you see that there were two variables, age and gender. During the pre-processing stage, you see that age data is not available for all the data points where the gender is, say, female. So here what you are saying is that there is some pattern in the missing data. Whenever the information which is collected for gender says female, you see that age is not mentioned. Now, basically what you are trying to say is there is some kind of a pattern here. The data is not completely missing at random. So here the probability of missing data depends on the observed data. So for this particular data set, I can say that if the gender is female, then the age is missing. So now we have a pattern. However, in case of MCAR, it was purely random. The probability of data missing was uniform. That is, it was completely random. It was not dependent on any other thing. Now, the third category of missing data is missing not at random. It is known as MNAR. It means that missing data have a pattern that cannot be explained by other observed variables. So we are saying that in all the data which is missing, there is a pattern. However, we cannot explain this pattern using the other observed variables. For example, in the previous case, there was a pattern that whenever the gender was female, the data was missing. So we had an observed variable which could be used to estimate or make a guess of whether age will be available or not. In this case, we are saying that there is some pattern, but none of the other data points which are available are able to explain this particular variation. So I hope this idea is clear that whatever data we have, if it is missing, it can be categorized into three categories. One is missing completely at random, where there is no explanation and no pattern in the missing data. Second is missing at random. In case of MAR, we are saying that the pattern in missing value can be explained by some of the other variables which are available. Third is missing not at random, where we acknowledge that there is some pattern in data collection. However, none of the other variables which are collected for this particular data point are able to explain this particular pattern. So the first step is to identify why a given data point is missing. Oftentimes, this basically helps us in understanding how should we go about handling the missing data. Now, we'll discuss some of the techniques for handling missing data. I'll repeat, I'll just give you an overview of different techniques which are available. As part of this course, the focus is not on understanding each of these methods in detail. I just want to give an overview that there are techniques like this which are available and they can be used in infrastructure decision making. So, how to handle missing data? There are several techniques. I have just classified them into two aspects: traditional methods and relatively new methods. Traditional methods include deterministic methods, mean, median or mode, using them as a substitute, interpolation, deletion and so on. There are some other traditional methods like random sample imputation or cold deck or hot deck imputation. I have not listed them here, but if someone is interested, you are open to exploring that. Also, in addition to traditional methods, there are relatively new methods which are being developed. For example, machine learning and AI is a growing area where a lot of these techniques are developed of how we can process and handle missing data. Integrative process, multiple imputation and stochastic processes. Let us see briefly what these processes are. First process is deterministic process. In case of deterministic process, the idea is that you make an educated prediction about the missing value and you use that value as if it was an actual measured data. So, in case of deterministic estimations, what you are saying is, say I have information about age of some students, there is a missing data point and I want to understand what could be the potential age of this particular student. Here you are saying that you just make a deterministic guess that maybe this particular data point will be 20, or you could say it will be 21. You just make an educated guess based on the information available. This obviously is a difficult step or a method because oftentimes it is difficult to identify appropriate substitutes. There can be bias and replacement. For example, when I said let us assume 20 or 21, I have a bias here that maybe the information collected for this particular student will be near these. So, there is a biasness. However, still this is one of the method which is commonly used, where based on the context, people who are taking this decision just use a deterministic value and use it for any decision making. Now, let us discuss another method. Obviously, deterministic methods have their own limitations. Another method which could be used is a substitution method, where you substitute the missing value using mean, median or mode. So, basically you are using mean, median or mode to substitute the missing data. The idea here is that if you have a large set of data points, then all the missing values are replaced by either mean or median or mode. So, if I have a data set where there are 100 data points like these, and I have the rainfall data recorded. So, say there is some information recorded at multiple places. Now, if there is any missing data, say record 20 is missing, then what we are trying to say is that for all the remaining 99 data points, we try to calculate mean or median and use that number here. So, this is another method. It is obviously simple to implement, and this particular method ensures that you still have enough sample size. For example, initially the sample size was 100. Now, since I have replaced this missing value with a mean or a median value, then I am ensuring that I still have a sample size of 100. Obviously, the disadvantage is still it is a biased estimate. Also, if there are multiple missing values, say for example, data point 3 is also missing, data point 10 is also not available, data point 28 is also not available, data point 99 is also not available. Here what we are saying is that all these data points 3, 10, 28, 20, 99 and so on will be replaced by the mean or median. Obviously, if we do so, it reduces the variance of the data set. So, this is one of the major limitations of using mean or median as a method for substituting missing values. Another aspect here is that the mean values which we use are often influenced by outliers. So, if your data set has extreme outliers, then the mean value gets influenced. Median is another method which could be used, which helps in overcoming this issue, because in case of median, the answers are not impacted by the outliers. So, that is just one reason where one could argue that using median is better than mean. However, in any of these cases, there is an issue of biased estimate, and also all the missing values are replaced by a single number. So, this is a major limitation of using substitution using mean, median or mode. Now, let us discuss another method. This is known as interpolation. In case of interpolation, instead of using mean or median, we are actually trying to interpolate information about the missing data. For example, let us assume there is information available about a student A. Now, we have information about this student from class 1 till class 12, and let us assume that we have all the information about student's height. So, we are recording the height of a student. Now, say you have information that the height of student class in class 1 is around 120 centimeters. Then in class 2, the height is 122 centimeters. Class 3, you have information that it is 125. Say in class 4, you don't have this information. This information was not collected. Then in class 5, you have information that it is 130 centimeters. So on, say at class 12th, the height is 170 centimeters. Now, what we are trying to say is that at class 4th, we don't have the information about students' height. Instead of using mean, we are actually relying on the two nearest values for interpolation. So we see that what is the height at age 3 and what is the height at age 5, and we try to interpolate to understand what will be the potential height at age 4. So in this case, interpolation basically would be something like 130 minus 125 divided by 5 minus 3. So basically you get 5 by 2 or 2.5, and then you add 2.5 to 125. So you make an estimate that the height will increase by 2.5 centimeter. So at class 4th, the height will be 125 plus 2.5, which is 127.5. So obviously there can be some data sets where instead of using mean, median or mode, it is better to use interpolation. This is one such example where what we are saying is height is likely to increase in every class during growing age. Now, if I try to take a mean in this particular case, some of the extreme data points like 170 or 120 will influence the decision. So it is better to use interpolation because we know that the height in the 4th class will be somewhere in between of what it was in 3rd class as well as 5th class. So this is a method of interpolation. I am sure all of you have learned about interpolation. The next method which is available to us is deletion. Often it is not preferred to delete a data point because you want higher sample size. However, if you have a large data set where you don't mind deleting a few data points, then deletion is again a good method which can be used for handling missing data, because you are not making any biased estimate. You are just removing the data points which are not available. However, this should only be considered in the case where the data is completely missing at random. So in case of deletion, there are two approaches. First is list-wise deletion and second is pair-wise deletion. In case of list-wise deletion, if there is an information which is missing about a given variable, then you basically delete that entire data point. So for example, if I am collecting information about 5 variables, variable 1, variable 2 and so on till variable 5, say for 5 students, student 1, student 2, so on till 5. Now, if an information about student 1 for variable 2 is not available, but all the other information is available. Basically, the idea is that even if a single data point is not available, I will go ahead and delete this particular item or this particular row. So any information about student 1 will not be considered in the decision making. So this is list-wise deletion. Pair-wise deletion basically says that if I am trying to analyze variable V2, then yes, information about student 1 for this particular variable is not available. So I'll go ahead and delete this particular student here from the data point. However, if I was doing an analysis for another variable, say V5, then since I have the required data for that particular student, I will not delete this particular student from the overall data set. So in case of list-wise deletion, even if a single variable about a student is not available, you delete that entire row. You don't really use any information about that particular student even for analyzing other variables. However, in case of pairwise deletion, if information about the given variable is not available and you need to analyze that particular variable, then you don't consider that particular row. However, for every other analysis around other variables, you still consider that row. So, pairwise deletion helps us in ensuring that we have a slightly bigger sample size. So, these are some of the traditional methods which are available. As I told earlier, there are other imputation techniques which are available. I am not discussing them right now. So, we have discussed 4 traditional methods: the deterministic method, using mean, median or mode for substitution, using interpolation and using deletion. One additional method which is commonly used is regression. Regression substitution is a very popular method which is used in the industry. In case of regression substitution method, missing values are predicted using a regression model. The idea here is that we are relying on other variables in the data set to make a prediction about the variable which is missing. This is especially suitable for data sets which are missing at random. If you remember, we had discussed that for any data set which is missing at random, the missing variable can be explained with the help of some of the other observed variables. So, here we actually use regression as a mechanism to estimate the missing value. I hope all of you can recall from your elementary mathematics that if there is an independent variable x and there is a dependent variable y, if we have information about different data points, for example, something like this, basically each of this data point is a coordinate known as x1, y1, x2, y2, xn, yn. Basically, what we try to say here is that if there are multiple data points, however, for some of the data points you don't have the dependent variable y, then you rely on all the other data points which are available, you plot it like this and then you try to create a regression line which basically tries to explain the relationship between y and x. So, this is a regression line which is given by y is equals to f of x, where you say that y is actually dependent on some of the other information which is available, that is x, and the relationship is y is equals to f of x. Now, for all those data points where y is missing, basically you have information about the corresponding x, you try to fit this particular function f of x and you estimate y. So, instead of using interpolation or using mean, median and mode, basically you are relying on all the other variables which are available. Based on those variables, you try to estimate y and then you try to use that particular value of y. So, regression is another method which can be used for substituting missing values. Here, the advantage of using regression is that the relationship between variables is taken into account. Second, it can provide more accurate estimates than some of the other methods which we have discussed till now. Disadvantage is there is an issue of overfitting. I am sure if you know about regression, you understand what is overfitting, and also there is an assumption that the relationship is linear. So, these are some of the disadvantages of using a regression based substitution method. Now, in addition to the traditional methods which I have discussed, there are some additional methods which are available in the literature. Anyone who is interested is encouraged to look into some of the available literature. Now, in addition to traditional methods, there are some relatively new methods which are developed. First one is machine learning and AI. There is a lot of discussion in machine learning, AI and deep learning space to create different techniques which can be used for handling missing data. A lot of these techniques are available which can be used for prediction. These techniques are found to be better than any of the traditional methods we use. However, any machine learning technique often requires a lot of data points for the model to be trained. Now, in addition to machine learning and AI, there is also a discussion of using an integrative imputation method for handling missing data. In case of integrative process, basically we are trying to understand correlations among multiple related data sets. So, till now we were discussing about a single data set and we were trying to assess how we can handle missing data. In case of integrative process, you look into other relevant data sets, and if information is available, you try to use that information, you try to do some correlation to basically understand if there is a better way to make an educated guess about the missing data. So, there is an integrative process which is used. Additionally, instead of a single imputation, there are discussions around using multiple imputation methods. In this case, till now we saw that we were trying to estimate a single number which could be used as a substitute for missing data. In case of multiple imputation, idea is you come up with multiple numbers which are plausible numbers which could be used to replace the missing data. So, you basically create multiple complete data sets by multiple imputations, and then you try to use these data sets to determine the final decision. So, the major difference between some of the deterministic or traditional methods and multiple imputation is that instead of making a single estimate, you are making multiple estimates. The moment we make multiple estimates, we will have multiple data sets. Each of these data sets are used for the analysis. Lastly, let us discuss what is stochastic method. In case of stochastic method, the idea is that the imputed values which we have are modified randomly to increase variability in the data set. So, till now we saw that whenever we are using mean, median, mode or regression based methods, the variance of the data set was going lower. This was actually impacting the characteristics of the population under consideration. A method which is suggested in the literature is to use stochastic representation where the imputed values are modified randomly by a small factor. So, typically the value which you get has a delta component which is basically determined using some probabilistic distribution. This helps in ensuring there is enough variability still left in the data set. Again, I will repeat that I have not gone into details of these methods. I am just trying to highlight that there are several methods which are available as far as handling missing data is concerned. So, these are some of the methods which can be used for handling missing data. In this particular lecture, we saw that missing data is of concern. So, we should employ different preventive measure techniques to basically ensure that whatever data we collect is of high quality and there are very low cases of missing data. However, it is a very difficult step. So, oftentimes we need to rely on basic imputation techniques to handle missing data. We have talked about some of these techniques. Finally, we also need to understand that even after doing imputation, although we are replacing all the missing values or we are just deleting a particular data point, this eventually is impacting our decision. So, we need to acknowledge this aspect that whatever data is missing, no matter what imputation, substitution, replacement, interpolation we have done, there is some level of biasness in that. So, we basically try to understand that what are the implications of missing data. We try to assume that what would have been the impact of this particular missing data on our decision. The moment we have used some substituted values, still we try to understand that does these substituted values have an impact on our decision. So, basically the idea here is that in this particular step, we are acknowledging that there was some missing data and we have used some assumptions to assume the missing data, and we should be aware of these assumptions when we try to assess the final outcome. Now, students are encouraged to go over these references if you want to learn about this particular topic. I hope that is clear. With that, I'll end my discussion here. Thanks for listening. Thank you.